Hey guys, we're on day 5 notes, and this just says log applications. All right, so most likely we'll be solving for exponent, therefore needing logs in these word problems. Okay, so number 1, it says it has been shown that homes in a certain city decrease in value at a rate of 2.5% per year if a home costs $42,000 in 2010 to the nearest tenth of a year. When will this home be worth 3/4 of its original value? Okay, so thinking about our exponential formulas that we have on our formula sheet, it doesn't say anything about half-life or continuously or compounding, and so I think we're going to go ahead and use the first formula, which is y equals ab to the x. I know it's got to be one of those formulas because I saw a percent in there. Okay. I also saw the word decrease, and so in my b value, I'm going to go ahead and put 1 minus, and 2.5% would be 0.025. Okay. If a home costs $42,000, that would be its initial value, which is our a. And they want to figure out how long, so our x is our question mark. That's what we're solving for. And then they said 3/4 of its original value. Hopefully you guys know 3/4 is 3/4. Okay, and so we could take 42,000 and multiply it by 3/4 or 0.75, either one. Okay, and so we're going to take 42,000 and we want to multiply by 3/4. Okay, or 0.75, which is what the decimal is equivalent to 3/4. And we end up with 31,500, and so that's our final amount. That's what our house wants to become. That's the amount of it. Okay. All right, we're just going to go ahead and plug them in to our formula. We'll have 31,500 equal to 42,000. In parentheses, 1 minus 0.025 is 0.975, and then raised to our x. Okay. Again, we're solving for an exponent. We know we need logs. However, when we use logs, we have to have our 3 things, our base, our exponent, our number. And if you look, we have 4 things right now. And so the thing that is extra is the 42,000. And so we're going to have to divide to get rid of it. Okay. When we do, we get a nice 0.75, which makes sense because it was 3/4 its value. And we don't technically need the parentheses around the 0.975 anymore unless you want them. All right, but we have our 3 things that we need in order to head into log form so that we can solve for that exponent. So we got the word log, our base, which is 0.975, of our number, which is 0.75, equal to our exponent or our x. Okay. Again, why that's helpful is this can be transformed into a division problem. Log on top, log on the bottom, 0.75 on top, 0.975 on the bottom, because the base, which is 0.975, goes in the basement or the denominator of our fraction. And we'll type it in. Don't forget to close the parenthesis after the 0.75 before you hit the division. And we should end up with 11.36283 ... And they asked us nearest tenth of a year. First decimal, look next door, and that's going to move it up. And so we'll say our final answer is 11.4 years. And that's how long it's going to take for the value of our house to go from 42,000 down to 3/4 its value with that rate of 2.5%. Okay, good. All right, let's take a look at number 2. Tony wants to start college. Okay, start a college fund, for his son Mark. He puts $57,000 into an account that grows at a rate of 2.85% per year, compounded monthly. Algebraically, determine the number of years it will take to reach 100,000 to the nearest hundredth of a year, given no more money was deposited into or withdrawn from the account once it was opened. Okay. I did see compounded monthly, and that is how I know we are using the second formula on our sheet. A of t equals P, 1 plus R over N raised to the NT. We have our 5 variables in there. And let's see which ones we know. He puts 57,000 into an account. So that's his principal. That's his P. That's his initial amount he's starting with. It grows at a rate. Well, this formula is used for growth, hence the 1 plus in the formula. So our rate is just 0.0285. Compounded monthly. The word monthly, since there's 12 months in the year, that refers to the number 12, and that's our N value. Algebraically determine the number of years it will take for it to reach 100,000. That is our output or our final amount. That's our A of t. And again, we're trying to figure out how long it's going to take. So that's our question mark. All right, let's go ahead and substitute in. So this is 100,000 equal to 57,000. In parentheses is 1 plus 0.0285 divided by 12 raised to the 12 times t, which is just 12t. Okay. All right. Again, we're solving for an exponent. We need logs. But in order to use logs, we need our 3 items, our base, our exponent, and our number. So we're going to go ahead and divide by 57,000 because that is an extra. Okay. You get a decimal if you math frac it. I don't know if you'd like to use the fraction better than the decimal. I'll use the fraction. It's 100 over 57. And at the same time, I'm going to go ahead and type in what is in parentheses here so that I can clean up my base. Okay. I'm going to type 1 plus 0.0285 divided by 12 in my calculator. And I end up with 1.002375 raised to the 12t. And now I have my 3 items, my base, my exponent, and my number, and now I am ready to go into log form. So I'm going to write the word log. Right next to the G, my subscript is my base, which is that 1.002375 number. Then next comes my number, which is my fraction, or you might have a decimal there that's equivalent to that fraction. And then equal to our exponent, which is 12t. Okay. Again, why this helps is because this can be put into my calculator as long as I change it into a division problem. Okay. So this is going to be log on top, log on bottom. The 100 over 57, or the equivalent decimal, goes on top. The 1.002375 goes on the bottom. And we have to remember that's equal to 12t, not just t. Okay. When I type it in, I get 236.9625 ... Okay, and that's equal to 12t. To solve for t, I have one last step to divide by 12. And t is going to come out to equal 19.746 ... They asked me to round to the nearest hundredth. So second place, look next door, and we're going to round up, and we're going to say our final answer is t equals 19.75 years. And that's how long it's going to take for his initial amount of 57,000 to end up at around 100,000 with that rate and that compounding. Okay. All right, let's take a look at number 3. It says Cody invests $12,500 at an annual rate of 5%. Compounded continuously. In part A, they want us to determine to the nearest dollar the amount of money he will have after 2 years. Okay, so because we sort of saw the word continuously, this will be our third formula down on our formula sheet, and it's PERT. A of t equals PE to the RT. We have A of t, P. Remember, E, guys, is in our calculator. It's not a variable we fill in. It's a constant, okay? And then R and T. All right, so he invests $12,500. That's his principal. His rate is 5%, so 0.05. And in part A, it's after 2 years. So we're solving for his final amount of money. And we'll fill it in. So we'll say A of t, or we could say A of 2. It does not matter. It won't affect our answer. Okay, and notice we are not solving for an exponent, therefore we don't need logs. This is actually back from Unit 5. We have everything we need, so all we have to do is go ahead and type it right in, 12500. Okay, second ln to get the e, raise it to the 0.05 times 2, and we have 13814.636, blah, blah, blah. Okay. They wanted us to round to the nearest dollar, which is this 4 spot, but look next door and it's going to round it up. And we will say our answer is $13,815. And that's how much Cody's going to have. Okay. Part B says determine how many years to the nearest year. Oop, that's not what I wanted to do. It will take for his initial investment to double. Okay. And so we have to realize that double is actually giving us a number, but we have to compute it. Okay. Remember what his initial investment was. $12,500. If he wants that to double, they're basically telling you to multiply it by 2, but they're not telling you that they want his final, his initial investment to end up being $25,000. They wanted you to find out that number by telling you to double it. Okay. And so now this is going to be our A of t. So we'll take our formula. Okay. We'll put that in for A of t. Our final amount spot. Our initial amount stays the same. Okay. E stays the same. His rate of 0.05 stays the same. However, this time we don't know how long it's going to take for that to happen. So we are now solving for our exponent. Therefore, we will need logs in this one. Okay. And in order to use logs, we need our 3 items, base, exponent, number. And we have a base of E. We have our exponent. But we can see, hopefully, that we have an extra of 12,500. And we're going to divide by it like we have been. And when we divide, we end up with a nice number of 2 since it doubled. So that makes sense. And now we are ready for logs. Okay. I'm going to just move this up a little bit. And I'm going to write the word log because I'm solving for an exponent. I know I need them. My base will be the E. So think about a shortcut maybe you can use in the next step. Then the 2, and then logs are equal to their exponent, which is why they help us solve them. Okay. I'm going to take that shortcut, and the shortcut I was talking about is that log with a base of E is really ln, or our natural log. Okay. If we hit the ln of 2 button in our calculator, hit enter, it's going to give you a decimal, and then I'm going to take that decimal and I'm going to divide it by 0.05. Okay. And you should end up with t equals 13.86294, ... They asked us to round to the nearest year, which is the 3 spot, but like next door, and that's going to round it up. So we'll say t equals 14, and this is in years. And so it's going to take Cody's initial investment to double. It's going to take about 14 years for that to happen with that information and that rate. Okay. All right. I will see you guys on the back side of notes for a few more problems.